Welcome. Today we are talking about understanding polynomial expressions. So a monomial is an expression consisting of a number, variable, or product of numbers and variables that have whole number exponents. Terms of expression are parts of the expression separated by plus signs. Remember that x minus y can be written as x plus negative y. The monomial cannot have more than one term, and it cannot have a variable in its denominator. Here are some examples of monomials and expressions that are not monomials. So here's expressions of monomials. We have a 4, it's a constant. It is by itself, it is a single term. There's variable x, it is a variable standing alone, it is a monomial. We have negative 4y or xy. This is a product of numbers and variables. Here we have a decimal times a variable with an exponent that has a whole number exponent. It's a single term. And then here we have xy divided by 4. You'll notice that in the denominator we do not have a variable, but we do have a 4, a whole number. These are examples of not monomials. Because of the plus sign here, 4 plus x, this is not a monomial because it has more than one term. Same thing here, x minus 1. This would be not a single term, so therefore it is not a monomial. This one, even though it has a decimal with a variable, you'll notice that the exponent is a negative power. And because it's a negative power, that means that if we were to change it to a positive power, that the x would be in the denominator. And remember, it said that we cannot have a variable in the denominator's place. Same with this one here. And again, with this one, we have a variable in the denominator's place. So to use the following process to determine if 5 times a times b squared is a monomial, well, it has one term. So it can be a monomial. Does it have a denominator? No, other than 1. If I put a 1 underneath it, that would have a denominator, but on its own, standalone, no, it does not. If possible, can you split it into a product of the numbers and the variables? Well, we have 5 times a times b squared, so yes, we can split it into a product of numbers and variables. And can you list the numbers and the variables in the product? The number is 5, and the variables are a and b squared. Okay, so that's proof that it is a monomial. So let's complete the chart below. We have x squared. Is this a monomial? Is it a single term? Yes. Does it have an exponent that's a whole number? Yes. Does it have a denominator with a variable in it? No. So the answer is yes. And it's because x squared is a single term with a whole number exponent. This one, the square root of y. This is no, because it's anytime you square root something, it's not considered a single term. This one, 2 to the second power, yes, is a product of a number in itself, honestly. It is a single term with a positive exponent, so yes. 5k squared. 5 over k squared, no, because there is an exponent, or there is a variable in the denominator's position. What about 5x plus 7? No, it's because it's not a single term. Okay, what about x squared plus 4ab? If you said no, you're correct. Again, it's not a single term. What about k squared divided by 4? Yes, this one is, because even though it has a denominator, the denominator is not a variable. All right, so classifying polynomials. A polynomial can be a monomial or the sum of monomials. Polynomials are classified by the number of terms that they contain. A monomial has one term. A binomial has two terms. That's what the word bi means. And a trinomial has three terms. That's what we call it when it has three terms. So if we have 8xy squared minus 5x cubed y cubed z, this is a binomial because it has two terms. Polynomials are also classified by their degree. The degree of a polynomial is the greatest value among the sums of the exponents on the variables in each term. So we're looking for the exponent with the greatest value, and that's your degree of polynomial. So the binomial 8xy squared minus 5x cubed y cubed z has two terms. It's a binomial. The variables in the first term are x and y. The exponent x is 1, and the exponent on y is 2. The number 8 is not a variable, so it has a degree of 0. The first term has a degree of 0 plus 1 plus 2 equals 3. So 1, 0 plus 1 plus 2 equals 3. The degree of the second term is 0 plus 3 plus 3 plus 1. 3 plus 3 is 6 plus 1 is 7. And so it has a degree of 7. Therefore, the greatest of the two values is 7, and therefore it is a 7th degree binomial. We'll do a couple more of those here in a minute. So take a look at your turn number 5, and we're going to classify each polynomial by its degree and the number of terms. I always like to start with the number of terms because that's the easiest part. So when I look at number 5, I have 3x squared y squared plus 3xy squared plus 5xy. I have 1, 2, 3 terms. So I have a trinomial. Now I'm going to take a look at the exponents. I have 0 plus 2 plus 2. That equals 4. I'm just going to put a little 4 underneath there. And then I have 0 plus 1 plus 2, which is 3. And then I have 5, which is 0, 1. 1 plus 1 is 2. So the highest or the greatest degree is 4. So it's the 4th degree trinomial. Take a look at number 6. How many terms does it have? 2. So therefore it is a binomial. And now count the degree. Two plus 1 is 3. 2 plus 1 is 3. The greatest exponent value is 3, so it's 3rd degree binomial. When we're writing polynomials, we try to write them in standard form. We like them to be written in descending order of their degree. So the standard form of a polynomial containing only one variable is written with the terms in order of decreasing degree. The first term will have a greatest value, the next term will have the next greatest, and so on until the final term, which will have the lowest degree. When it's written in this form only, the coefficient of the first term is called the leading coefficient. So we'll take a look at 5x to the 4th power plus 4x to the 2nd power plus x minus 2. You'll also notice that the variable, if I did this one, 0 plus 4, this is 4. 0 plus 2 is 2. 1, and then there's 0. So it's in descending order, 4, 2, 1, 0. If it contains one variable and its first term is, so in this case, the coefficient of the leading is 5. So my leading coefficient is 5. It's in the front of the highest degree term. That's important. You don't want to just look at it as it's originally written. You want to rewrite it in standard form and then determine what the leading coefficient is going to be. So we're going to write each polynomial in standard form and then give the leading coefficient. So on number 7, I want you to take a look at each, and I want you to determine what the degree is for each term. Okay, so you should have found them that they are in this order. And so now that you've seen them, which number would come first, or which term would come first? If you said x to the 5th power, you're correct. So we would go in descending order, where this would be their first one, this would be my second, this would be my third, and this would be my 4th term. It's also important when you're writing this that this whole thing here is the term, and so the minus sign goes with the 3x squared. Now, if I have to find the leading coefficient, I'm going to look at the very beginning, in this part right here, and you'll notice there's nothing there. And we know in front of every variable that stands alone, there's always an invisible 1. So that means my leading coefficient is going to be 1. Okay? Take a look at number 10 and write it in standard form and then give the leading coefficient. So here it is in standard form. And then I wanted to take a look at this -7 plus 7. I can simplify that to be 0. And so if I were to write it in correct form, I would get rid of this part because that would be plus 0. And now tell me what the leading coefficient is. And if you said 12, you were correct. We can simplify polynomials because we can combine those like terms. And like terms are monomials that have the same variables raised to the same powers. The unlike ones will have different powers. So when I do these, I always look to see if I have variables with the same power, or if I have just constants, and then I can combine what I see. And so when I'm looking at r squared plus 5r cubed plus 2r squared, I see that this one has a square and this one has a square. So these two are like terms, and so that would be 3r squared. And then I have plus 5r to the 3rd power. If I were to write it in standard form, which one would come first? And if you said the 5r cubed, you were correct, because cubed is larger in degree than squared. And so this would be your simplified expression. So let's simplify number 12. There's a lot of P's and Q's in this one, so I like to highlight. It makes it much easier when I'm working through these to determine what I can put together. So I have p squared q squared, and then I have p squared q squared here. So these two are like terms. Really don't like those colors. Let me see if I can get a lighter color. Let's do this. This one and this one. Then I have p squared q to the 3rd power, p squared q to the 3rd power. And so for those, let's use this other color. So I can combine these two as well. And then I have PQ off to the side. So when I take a look at these and I'm trying to combine like terms, I look to see what the constant in front or the coefficient in front are. So I have 3 minus 3. Well, that's 0. And 0 times p squared q squared is 0. So those actually cancel each other out. So we no longer have these two in the picture. Then I have negative 3 plus 4. Well, negative 3 plus 4 is 1. And so I'm going to have p2q cubed plus pq. And I'm going to look at the degree. I have 5 and I have 2, so 5 comes before 2. And then if I needed to ask what the leading coefficient is, I can look in front. There's nothing there, so I know it's 1. Take a look at 13. This one's done a little differently, and there's two ways you could do it. You could distribute everything and then combine like terms, or you could take a look at what they're being multiplied by and see if you have a like term there. When I look at this, I see that in this parentheses I have 4 plus b, then I have b plus c, and then I have a minus c. So none of these are the same. So in this case, my best bet would be to distribute. So I'm going to distribute the 3. I'm going to distribute the negative 6. And then I'm going to distribute the 8. Okay, now I'm going to find all my like terms. So I have a 3a and an 8a. So 3a plus 8a is 11a. Then I have a 3b minus a 6b. Well, 3 minus 6 is negative 3, so minus 3b. And then my last ones are c's. And I have a negative 6c and a negative 8c. And when you add negative 6 plus negative 8, I get negative 14c. All right, take a look at 14. What like terms can you combine? Okay, so I found my like terms, ab, and then a squared, and then my constants. Now I count this as a constant because there's no variable. And so I know that if I take 4 squared, I get 16. And 16 and 10 are constant numbers. So now I combine my like terms. ab minus 5ab is negative 4ab. And negative a squared plus 3 squared is 2a squared. And then I have 16 plus 10, I get 26. Now, when writing this in standard form, I have two choices. I can choose to move the 2a squared, or I can leave the negative 4ab in the front. Personally, I like my first numbers to always be positive, so I would write it as 2a squared minus 4ab plus 26. And if I did it this way, my leading coefficient is positive 2. Okay, Lisa wants to measure the depth of an emptied well. She drops a ball from the height of 3 feet into the well and measures how long it would take the ball to hit the bottom of the well. She uses a stopwatch, and starting when she let go of the ball and ending when she hears the ball hit the bottom of the well. The polynomial negative 16t squared plus 0t plus 3 gives the height of the ball after t seconds, where 0 is the initial height or initial speed of the ball, and 3 is the initial height of the ball that it was dropped from. Her stopwatch measures 2.2 seconds. That's in seconds, and we know that t is the number of seconds. So the first thing we're going to do is we're going to write the expression down. And we're going to substitute 2.2 for t. So we have negative 16 times 2.2 squared plus 0 times 2.2 plus 3. And now we're going to simplify using our order of operations. So you can see where I squared my 2.2 first, and I got 4 1/84. Multiplied that by negative 16 and got negative 77.44. 0 times 2.2 is 0, and then bring down my 3. I take negative 700 or 77.44 plus 3, and I get negative 74.44. And that means that the ball drops 74 and 44 hundredths of a feet below the ground, and therefore it is negative 74.44 feet deep. If you have any questions, please make sure you see your teacher. Thank you.